Hi all. Just thought of taking you guys through application of Snell's law when it comes in a question. So imagine there is a situation where you have an incident ray. This is your incident ray. This is your incident ray, which is incident at 30 degrees to the normal, and it refracts from this surface AB. Imagine. And you can clearly see, because it is going from a dense medium to a rare medium, the refraction is away from the normal. So it creates an angle R over here. So you're going to apply Snell's law to this surface, to this interface, right? Given that this is glass and the refractive index is 1.41, this is the given value. And air, of course, what we have taught you, you can take refractive index always as 1 for your level, because we assume air, the light traveling through air to be similar to light traveling through a vacuum. So we take n of air as n equals 1. So we apply Snell's law to this surface with it, right? So the application of the application of Snell's law, you can do it this way. So you can take sine of I, right? So you know Snell's law is sine I, right, over sine R is a constant, which is known as refractive index, So this is basically right. So as you guys all know, sine law of the Snell's law is sine I over sine R is a constant. The constant is n, which is refractive index. But this has to be modified, right, in a way that you can apply for a question. So I'm going to show you how you can modify this Snell's law to be applicable for a question. So we apply Snell's law to this surface today. You need to write in this. So you need to write it is coming from air. So from which medium to what medium? It is going from air to glass. So I start with air. Na sine I. That is the part which is in the first phase. This is the part that is actually in the first medium. The rest of it is in the second medium. Should be equal to n of g. What is your second medium? That into, so in the second medium, you are supposed to have the refraction part. In the first medium, you are supposed to have the incident ray. So incident part. So I write the incident part in the first, as the first part of this equation. And the second part of the equation, I write the rest of it, which is the refractive index of the second medium into sine of the refractive angle, right? Refraction angle, right? Angle of refraction. So this is the way you should apply Snell's law, right, correctly for a question, right? So if you go for the values, you can see NA is 1 multiplied by sine of I. This is your incident ray. That's your incident ray, and this is your refracted ray, which is inside the glass block, right? So sine of I is sine 30. Sine incident angle is 30. Can you see? Incident angle is 30. Should equal to Ng, which is given to you 1.41 into sine of R, which is occurring inside the glass block. Sine of R is what you have to find. Now let's take your calculator and put up the values. Sine of R, sine of 30, right? Sine 30 is 0.5. Sine 30 is 0.5. So 1 into 0.5 should equal to 1.41 into sine R. So you don't know sine R. We will subject sine of R, which is equal to 0.5 divided by 1.41, which is equal to this value. And therefore, you need R, not sine R. You need R. So basically, your R will equal to sine inverse of this fraction, 0.5 divided by 1.41. So take your values. So 0.5 divided by 1.41, right? 0.5 divided by 1.4. It gives you 0.43. So about 0.44. That is the answer of this fraction. So sine inverse of this, right? So you can type shift sine of 0.44. Right? Shift sine 0.44 will give you this answer, which is equivalent to 20 approximately, right? Approximately 26.1 degrees. So that should be your answer, 26.1 degrees, right? I hope you can see, right? I hope you can see. So R equals to 26.1 degrees. So that is your answer for the angle of refraction. Now you can try applying Snell's law to this interface as well. If I name this as CD, AB, CD. If I name it as CD interface, so you can see this refracted ray travels inside the first medium, and there is a place where it goes to second medium. So going from one medium to another medium, refraction occurs. So when refraction occurs, you can apply Snell's law, right, to find either of the parameters, right? The refractive index of first one, or refractive index of second one, angle of incidence, or angle of refraction, right? So you have 4 parameters, 3 will be given, right? 3 will be given, 3 will be known. You can find the unknown 4th parameter. So in this case, you can say this is parallel lines. It's a glass block, parallel lines. So this angle R will equal this angle. So angle 26.1 is the value you can take here. 26.1 is the value you can take there as well, because this is a, or you can take it as a what? Z angle, no? Z angle, alternate angle. You can take it as an alternate angle. So this R should equal this R, this angle. This angle we have found as 26.1. So this R should be 26.1 as well. So there is, so in this case, now this refracted ray for the first case will act as a incident ray for this surface, for this interface. This ray was a refracted ray for this first surface. This refracted ray now acts as an incident ray for this surface. And this is your incident ray, and this becomes your refracted ray. Actually, this is your emitted ray. This is your ray of emission, emitted ray. When you compare it with this ray, if you compare it with this ray, this is your ray of emission. But here, for this case, you can take it as a refracted ray. You can take it as a refracted ray from this surface CD. Okay. If I apply Snell's law there, now you can try. Now you can try applying Snell's law there. Right? Let's apply Snell's law. Right? This is the Snell's law, but this has to be modified, right, in such a way you can apply in questions. So how do I apply it? Refractive index of the first medium. So in my case, refractive index of the first medium for this case is your glass. So that into sine of incident ray. So in this case, sine of the sine angle is this R, 26.1, because this becomes the incident ray for this case. For this second case, sine of 26.1 should equal to refractive index of the second medium. I'm going to air. So refractive index of air multiply by the sine of the refracted angle. Right? So these values you know, this value you know, this value you can get, this value you know. Here also easily you can find answer for the angle of refraction. It should be 1.41, right? 1.41 into sine of 26.1. Sine of 26.1 is 0.44. That divided by angle refractive index of air, which is 1. Thus you can find R equals sine inverse of this answer. 1.41 multiplied by 0.44, right, which is equal to 0.6262, and therefore your R should be equal to sine of anti-sine of, right, sine inverse of 0.62, which is sine inverse of 0.62 will give you something around 38. something around 38. So that means you can take it as an answer, right? 38, approximately 38.3, I would tell you. Right? So here there is something you should understand, right? Ideally, if you take an ideal scenario, right? Ideal scenario, angle of incidence here should be the same as angle of emission here, because it's the same medium, right? After the second medium, after traveling through glass, right? This ray is entering the same medium. It is from air going to the glass, going through glass, entering the same medium air. So ideally, right, the ideal scenario is you should have the same angle of incidence here and the same angle of emission there, right? So due to our rounding off during the calculation, we round off, right? These values we have rounded off, right? So because of this rounding off today, we have got a slightly different value, right? Actually, not slightly, but ideal case is you should get the same answer. But because of our rounding offs, right? We have rounded off the answers, right? When you are taking these answers. Because of that, we have got a different answer. So in a question, if they ask you what is the reason, right? Okay, the real answer should be different, should be the same as incident angle, but you have got a different answer. What could be the reason? Basically, because of the rounding off of these answers during our calculation. Right, guys? I hope this is clear. Good luck for your exams. Take care. Bye.